Hi, welcome to today's lesson on similar shapes. This one actually is a lot of vocabulary, definitions, examples of definitions. Not a lot of math for us to work on here, so you're not going to see too many examples. You're going to see a lot of definitions, vocabulary. Maybe I'll even just explain more than I will write, just because, as you guys still know, this is this arm is still healing. Probably shouldn't use it too much. So let's start with what do I mean when I say similar. So again, we're going to talk about vocabulary, and when I say similar, we're always going to be talking about shapes. And this is definitely, whoops, not a T, similar. It's supposed to be an L. It is specifically talking about shapes. Okay, so rectangles, triangles, the like. Mostly triangles. You're going to find probably when we talk about shapes being similar, probably 90+% of the time we're talking about triangles. Okay, so what does it mean for two shapes to be similar? Well, first of all, they obviously have to be the same shape. They have to be triangles or rectangles or whatever. Okay, but really the big thing is that all corresponding, here's again another word we may have to talk about, angles are congruent. So here's a whole bunch I'm going to have to explain. Corresponding means they sit in the same spot on each triangle. Okay, and that might change. It might visually change if one gets rotated or flipped or something. But when you look at if you have, let's say, a right triangle, the right angle is always the right part of the right triangle. And when they line up, even if they're not like sitting in exactly the same spot, so like if I gave you, so here's a right triangle, and let's give a smaller right triangle. So those might be similar. I don't know yet if they're similar. In order for me to know if they're similar, I need to know that all their corresponding angles are congruent. And congruent is just a fancy way of saying equal. So I need to know that this angle with the little box is the same as that little angle. The box tells me it's 90 degrees, so that tells me they are the same. The next way that I indicate that angles are congruent is with like a little line. And it's a little curved line. That's an angle. That angle matches this angle. I get it with one line. If I want this angle, which I indicate with 2, matches this one, which I indicate with 2. Now I know all the corresponding angles are congruent. This angle matches this one matches this one, and this one matches this one. Now if I flipped it around or I rotated it, it wouldn't matter, because those lines are telling me and telling you that they are congruent. Once I know that all the corresponding angles are congruent, I know the two shapes are similar. Now, what does that tell me? Let me label these. So we're going to make this triangle A, B, C. We'll make this one real easy, D, E, F. So I know that angle A and angle D are congruent. Now, how do I write that? How can I show that to somebody else who just walked up, maybe just turned on the video? Well, I indicate with a little symbol that looks like that. That's a symbol for angle. And then I put the letter A. Okay? Now, that angle it's not equal, it's congruent. We indicate that with an equal sign and then a squiggly line over it. Honestly, it does mean they're equal. I'll show you what that in a second. It's congruent to angle D. That means the measure, which we abbreviate with the letter M, of angle A is equal to the measure of angle D. Now, why do we have these different things? I don't know. Makes math people feel smarter, I guess. But they mean the same thing. Telling me they're congruent means their measures are equal. Telling me their measures are equal means they're telling me they're congruent. Putting the same little box tells me they're the same. So if I told you the angle A is 90 degrees, then you know that angle D is 90 degrees because they're equal. They're congruent. You name it. Okay? Now, occasionally, you will see an angle referred to by 3 letters. Now, why would we do that? Well, 2 reasons. One, well, really only one reason, because we have to. I guess the other one would be because we can. I could have, instead of saying A, I could have said angle BAC, a starting point, a midpoint, and an end point to tell you which one. Now, why would I want to do that? Well, what if I had a line and I cut it here and I wanted to talk about, oh, I'm going to put a dot, I'm going to give this, call this A, call this B, C, and I'm going to call this D. And I want to talk about this angle. Sometimes you think, well, I'll just call it angle B. But couldn't angle B have been that side? So how do I determine, how do I tell you which one I'm talking about if there's more than one choice? Well, I say, if I want to talk about this one right here, I would say that is CBD. Because now you know I went from C to B to D, and that's the angle that I'm talking about. So when you see it in assignments, when you see it in texts, when you see it in homework, and you're seeing, hey, sometimes they give you 1 letter, and sometimes they give you 3 letters. Why? Well, because here I only need 1 letter. There's only one angle A inside this triangle. But over in this part, there could have been 2 different angle Bs. So I had to tell you which one I was talking about. Okay? Now, when I tell you that when I tell you all the angles are congruent, then I'm telling you the 2 shapes are similar. And vice versa. If I tell you that the 2 shapes are similar, I'm telling you that all the angles, A matches up with D, B matches up with E, and C matches up with F. And in fact, I would write this out as one thing called a similarity statement. This is kind of a big deal because this is something that you can write, and if a person walks up to it who's a math person who understands this like we're about to, then they would understand a ton of information. And it would look like this. Triangle A, B, C is similar. And we draw it similar. It's like the top part of the congruent without the equal sign, because it's not equal, it's similar. Here it's exact. Here it's similar. To triangle D, E, F. And I'm not going any lower than that. The reason that this is so important to us is it tells us a ton. It tells us all kinds of things. In fact, what I'm going to do here in just a second, I'm going to erase all this, I'm going to write this at the top, and then I'm going to talk about all the things that it tells us. Because it tells us a lot of information, and it's something we can all use quite. We're going to see it again and again and again. You will see it when you get into higher levels of math, more difficult concepts, is what is this, why is it so important? And again, similarity comes back to scale factor, which we're going to see here in just a second. So let me pick up that eraser I dropped a second ago, get rid of all of this. And I'm going to write that similarity statement right here at the top. So triangle A, B, C, oops, I got a triangle. And if I were using a different shape, I'd use a different shape. I mean, if it were rectangles that were similar, or you might see in your homework, you might see pentagons that are similar, or, it doesn't matter. You can make any shapes that are similar. And I indicate it by drawing the actual shape. It's a triangle. So triangle ABC is similar to triangle DEF. So again, a lot of information is there. Now we already said that every angle is congruent to every other angle. So again, I can say angle A is congruent to angle D. And that's also because of where they sit in the similarity statement. They're the first letter of each triangle, then they're the ones that are similar. No matter where the drawing is. I see, I'm not even giving you a drawing. But if I did, I would know which letters, which angles are congruent, because the statement tells me. Now I can keep going, but for sake of saving my arm, B is congruent to E, C is congruent to F. Okay, it's all that information is there. The other thing that really jumps out at us that becomes a huge deal is that the distance from A to B, which I will literally, with a little line segment over it, telling me the distance from A to B is congruent. Sorry, it's not congruent. My bad. Excuse me. Divided by the distance from D to E. So on the triangle, the side from A to B divided by the side from D to E is going to be equal to the distance from B to C divided by the distance from E to F, which is going to be equal to the side A to C to D to F, and that is the scale factor. Remember from our last lesson, that's the scale factor from one similar shape to another. So we have this thing called a similarity statement. That similarity statement tells me that every corresponding set of angles are congruent. A equals B, sorry, not B. A equals D, B equals E, and C equals F. It tells me the distance from A to B, the first two letters, is the same, divided by the distance from D to E, is the scale factor. And that scale factor is true for every set of sides. B to C is E to F, A to C is D to F. So if I had these two drawings, let's see if I can make two reasonable triangles. So here's my ABC, and here's my DEF. So I know that this angle is the same as that angle is the same as that angle, and that one's the same as that one. I also know that this distance divided by this distance is going to be exactly the same as this distance to this one and this one to this one, aka the scale factor. Now, if someone came along and told me either what the scale factor was or just gave me two measurements, then I would know the scale factor for the drawing. I would also be able to come up with the rest of the sides if you gave me one or the other side. So if I told you this was, let's just go 5, and we'll make this one 2. So 5 to 2. If you tell me this one, I'll be able to figure that one out. The scale factor could be 5 to 2. And it does, again, remember I said it normally is small to large, but it doesn't have to be. Okay? From the big to the small is 5 to 2. From the small to the big is 2 to 5. The relationship doesn't care which direction it's going, as long as you understand bigger number, bigger shape, smaller number, smaller shape. It's pretty straightforward. So if I gave you this number, you would be able to figure this one out, or vice versa. I give you the small here, you'd be able to figure that out, because you have the scale factor, and then all you need, again, you can make a proportion, and I need one of these two numbers. You give me one of those two numbers, I cross multiply, divide, and I'll find out the missing side. Again, I probably would have liked to have done maybe a little bit more with some more numbers, but I think this is actually pretty straightforward, and maybe it's better without, just to kind of abstract it. Okay, there's really only two things we care about with similar: that all the angles that correspond, that match up, are the same, and that there's this ratio between the sides that is the scale factor. Okay? All right, then I hope that's helpful, and let me step aside so you can get one more good look at it, and then I will see you in class or in office.